Hi, welcome to this video lecture. Pangalan ko ay Nick Agriam, kagaya nakikita nyo dyan. I will be discussing mathematics based on the government-issued book for grade 8, mathematics for grade 8. I will try to speak English as good as I can, pero pag sa tingin ko ay kailangan ng Tagalog. Kailangan kong i-explain sa Tagalog at kaya kong i-Tagalog kasi hindi ko naman yun ang mother tongue ko, Tagalog. I-explain ko siya. Okay. Gusto kong magsimula sa special products. Yan yung gusto kong i-start. It is under the topic multiplication of polynomials. Maybe in grade 7, so natutunan nyo ito. If I multiply A by B and C in a parenthesis, then I will multiply it A and B, and then A and C. Yan yung natutunan natin dati. Remember that if I will multiply two variables, then I am talking about area. Laging ito ganito to. So if I am multiplying AB, for example, this is my A and this is AB. The area of this figure is AB. Then it is always area. When we have the degree, pag degree natin ay 2 square, laging area ang pinag-uusapan natin. Okay. Kahit mag-multiply ako ng A plus B in a parenthesis, multiplied by C plus D, multiplying A and C, AC, and then A plus D, A multiplied by D, that is AD, and then B multiplied by C is BC, B multiplied by D is BAD. That means if I am going to divide this rectangle into 4, for example, this is A, and this is B, and then we have C, and this is D. This AC here that we multiplied is this area. AD is this area. And then we have the BC, this area, and the last one, BD, this area. As you can see, when we talk about products of two variables, it is always an area. Remember that. Kasi kailangan nyo yan sa special products. Okay, let's see if we can take some special products now. The first special products that we're going to discuss is the square of a binomial. Square of a binomial. Okay. As you can see, I have a figure here. The side is A. So the area is A multiplied by A, or A squared. So the area of this. But if I'm going to extend this square to a bigger square, then I will tell this is A and this is B, and this is still A and this is B. That means the area of this is AB, and the area here is also AB. But this area is B squared, because this is B and this is B. That's B squared. Let's see. So if I have A plus B squared, square of a binomial is the same as A plus B multiplied by A plus B in a parenthesis. Both are in the parenthesis. Maybe, before I go further, remember this. A multiplied by A is A squared. Why? Because we can add their exponents. 1 plus 1 is 2. If we have the same base, we can add their exponents. That is one of the laws of exponents. Sorry for that. And then because of this, we can remember this that I discussed. This one, we can do the same. Let's see. A multiplied by A is A squared. And then A multiplied by B is AB. B multiplied by A is the same also as AB. Reminder again, AB is equal to BA. It doesn't matter. The arrangement of the variables doesn't matter. And then we have the last term is B times B is B squared. If we simplify that, it is A squared plus 2AB plus B squared. This is the pattern. It doesn't matter how they look like. It always follows this pattern. That is why it is called one of the special products. In the same manner, if we have A minus B squared is equal to A minus B, A minus B. That means if we multiply A plus A multiplied by A is A squared, and then we have A multiplied by negative B. We need to include even the negative symbol, and we have negative AB, and then negative B multiplied by A is negative AB, and then negative B multiplied by negative B is positive B squared. Simplify that, then we have A squared minus 2AB plus B squared. So, to sum it up, we have A plus B squared, square of a binomial, and we have A squared multiplied by, I add by 2 multiplied by, as you can see, the product of the first term and the last term plus B squared, or the square of the last term. And if we have A minus B squared, it is also the same. The only difference is the negative 2 plus B squared. Let's see some example. Let's take some examples. For example, I have x plus y in a parenthesis, and the square of x plus y. And then we have the first term, square of that, and then we have the 2 multiplied by the first term and the last term multiplied by, and then the last term square. That means we have x squared plus 2xy plus y squared. Let's have another. For example, we have 3x minus 2y squared. Then we have the first term, 3x squared minus 2 multiplied by the first term, so 3x multiplied by the last term, negative 2y. No, sorry. It's just 2y. And then we have plus, according to here, is just, we don't consider the sign here because it's already here. So remember that. And then we have the last term. We have the 2y squared. In the last term, you can even use minus 2y, but it doesn't matter. So I will remove that. Then simplify. Then we have 9x squared. And then we have 2 multiplied by 3 is 6, multiplied by 2 is 12. So negative 12xy. And then the last term will be 4y squared. Let's take some example. More examples. For example, you are asked by your teacher to multiply 99 by 99 using other methods that what you have learned before. Then you can say that you can use this 100 minus 1 square. That is also 99. Then you can use what you have learned now. We have 100 square minus 2 times 100 times 1 plus 1 squared. Then we have 100 by 100 is 10,000 minus 200 plus 1. Then we have minus 200 0, 0, and then we have 8, 9,800 plus 1, then we have 9,801. Or you were asked to multiply 5 times 205. Then you can use 200 plus 5 square. Then we have 200, that is 40,000. Plus 2 times 200. I will use this. Times 5 plus 25. Then we have 40,000 plus 10 times 200, that is 2,000 plus 25. Then we have 40,000, 42,025. So I hope you have learned something about my discussion in the special products, especially the sum and difference of two binomials, the square of a binomials, I should say. See you next time.